Welcome to my presentation on Assessment 2 of SIT718. Today in the analysis, there will be a dataset on energy appliances with a total of 5 X features and 1 Y variable of interest. The dataset contains numeric values with total of more than 19,000 rows and 7 columns, and will use a sampled dataset of 450 rows. To gain more insights into the dataset, I have computed the skewness as well as plotting the histogram and scatter plot. So if the skewness is within the range minus 0.5 to 0.5, and according to the histogram, we can see if it's a normal distribution or not. And based on the scatter plot, we can also see the correlation of the variable with Y. So X1, it's slightly positive skewed with a positive correlation. X2, it's normally distributed with a slightly negative correlation with Y. Both X3 and X4 has a normal distribution, and X3 is positively correlated, while X4 is negative correlation. X5, it's also normally distributed with a negative correlation with Y, and our variable of interest Y, it's highly positive skewed with skewness of 2.94. Looking at the range of all of the variables, we can see that all of them are out of the range from 0 to 1 based on their mean and max values. So we'll have to do normalization later on. About the correlation matrix, we can see that X1 and X3 had some moderate correlation, but it's not too extreme. And X1 has the highest correlation with Y. Meanwhile, X4 has the lowest correlation. So we'll drop X4 in before our data transformation. So as above mentioned, X2 and X5 has a negative correlation with Y. So the first step is to do negation transformation on these variables. The next step is to handle the skewness of X1 and Y. So we'll do log transformation for them. And the last step is to do min-max transformation to put all of the variables within the range 0 to 1. After transforming the data, we can see that all of the histogram now resemble a normal distribution, except for X1 and Y, it still have a high skewness. However, because log transformation is quite extreme and we do not want to reduce the interpretability of this variable, so we keep it like that. The range of all variables are now within the range 0 to 1, and we can see that correlation is much more improved. And after feeding the models with the dataset, we can see that weighted arithmetic means has the lowest RMSE and also has the highest Pearson and Spearman correlation. On the other hand, ordered weighted averaging has the lowest average absolute error. However, this is the only model that retains X3, and we want to retain X3 in our model fitting. So I would choose OWA as the most suited model. And depending on the weights of OWA, we can see that X1 has the highest importance, then X3, then X2, and X5. And then we can use OWA and the provided inputs of X to predict the value of Y. So after all of these steps, we get the value of Y predicted. It's 64.68, which is only 4.68 higher than the actual value of Y with equal to 60. So we can say that the model is quite accurate. So after the analysis, we can see some results about how to lower the energy consumption. Because X1 and X3 has the highest importance to the energy consumption, we can see that the favorable condition is to keep these two low, and we keep a stable level of humidity and pressure. Some implications and limitations to the analysis. First thing is that it emphasized the importance of indoor temperatures variables, X1 and X3. The second implication is that there will be more, it shows the effectiveness of pre-processing steps, and also it supports the development of data-driven approaches in lower energy houses, contributing to sustainable practices. There are some limitations. The first thing is there will be potentially better models, which is not included in this assessment. The second thing is that the model may miss complex nonlinear relationships that could improve the predictive power. And lastly, the dataset is on a controlled low energy house, so it might not directly translate to conventional settings or extreme environmental conditions. Thank you for listening.